Hi, everybody. I'm Scott Lappin. I am from Panera Bread, and today we're going to talk to you a little bit about what we've done with Chef Infra and Habitat and CI/CD as a whole at Panera Bread. Some pretty cool stuff, and I hope you guys find it interesting. We have a panel today of some super smart people to help us guide us along the way and answer the questions that I can't. You see my picture there. I'm Scott. Mike, you want to say hi?
Yeah. Hi, guys.
Mike is my lead developer on the project. Greg Schofield.
Hey, I'm Greg Schofield. I'm a senior DevOps specialist at Endelliant. And just a super quick plug, we just released a no-code CI/CD SaaS system at ShutOps. Please check it out.
We brought Greg in to help. Actually, Chef helped us bring Greg in to help with this project, and we could not have done without it. He was a fantastic resource. Matt.
Yeah, I'm Matt Rock. I'm a principal engineer on the Habitat team, working mainly with Habitat on Windows.
And last but certainly not least, Eric. Eric was invaluable in this. Eric from Chef. Hopefully a lot of you know if you don't know this guy, because he is worth knowing for sure.
Thanks. Yeah, I'm Eric Calabretta. I'm a lead solutions architect for Chef.
All right, with that, we will get started. You can see here what our agenda is. We're going to basically go over what we've done, what our problems were, how we tried to solve them. It'll only take a few minutes probably because there's not going to be a lot of people here to raise their hands. And then we can go into the Q&A afterwards, and me or the panel will do our best to answer any questions that we possibly can. So Panera and Panera DevOps, we started our journey about 3 years ago. Panera Bread, hopefully all of you know about. We have about 2,000 stores across the US and Canada. We built our own proprietary point of sale software, mainly because the third-party software that we had just couldn't keep up with the feature requests that we had. If you used our e-commerce, our mobile apps, which I hope you have, what our business wanted, it just couldn't happen fast enough. And so we brought in, DevOps and our own point of sale to try to handle that scale of the feature requests we really needed to do. We built out an internal team to try to create a model for everybody to follow and have a basic set of services that people can use to build, test, deploy software. That is a similar approach, at least across the data centers and the cafes. Currently, we have around 12,000 machines that are managed under Chef Infra and about 58,000 Habitat applications out there. That's a lot. A lot of you are probably wondering how we have that many for Panera, but we'll get to that at some point. Just an idea too, our IT department's probably about 400 people. I'd say we have about 100 developers, somewhere in that ballpark. And as you can see, we're averaging about 28,000 builds a month. So we're doing a lot, we're moving fast. And we're hoping to move even faster and safer here in the future. Our cafe infrastructure is what we're mainly going to be talking about here. When you go into a Panera, and again, hopefully all of you have been there, you'll notice when you walk in, there's the point of sale, the POS, we call it the point of sale, where you walk up to place your order. There are kitchen display systems in the back. So once the order goes in, the order displays in the kitchen in the back, and that's where your sandwiches are made and all that. They're running either Windows 7 or Windows 10. And we have Chef and Habitat managing about 7 microservices around the different applications. We also have a compute node in the store, a Linux Red Hat server for what it is. All our corporate stores currently have that in there. It's about a little over 1,000 stores right now that their compute nodes are managed by Chef Infra and Habitat at this point. The network connectivity, you'll hear some more about this, is interesting. We have basically a T1 connection to every store. So what I really want you to think about as we talk through this thing is that we have approximately 2,000, a little over, data centers with, as you can see here, anywhere from 6 to 15 devices connected, and we have to manage across a T1. Not incredibly reliable. Some of them are down, some of them are up. Problems that we had to face like that. We also have our data center where our e-com apps run, and they are running under Habitat and Chef Infra as well. It's on-prem. That is our on-prem Habitat server, the builder, the Chef server, Automate, all that kind of stuff. Everything you'd expect to have in a data center. Here's a good design idea, pretty picture that you guys can look at later. But it gives you an idea of what happens, right? We follow GitHub, or just a Git model of anything committed will go ahead and be built and deployed as you would expect. So the build occurs, it goes to the Habitat builder, and then it's either pushed to the blade or to the point of sale and kitchen devices. This is showing the permanent pier being the blade, and the proxies being our proxy, as well as a Habitat ring here for each of the devices to be able to consume some data. We'll give you some more on that in a little bit, but this is just a pretty picture to kind of show you the flow, how it goes. Guys, if you want to jump in, yeah, please.
Yeah, one of the things I wanted to point out here is if you look at the data center, you see there's no Chef infra server, and that might be something to call out because we took our cookbooks that we wanted to manage and we moved them into Habitat using the Effortless model. So there's no Chef server to actually connect back into to bootstrap these servers. They're all run using the Effortless model.
Yep, that is true of the point of sale systems. The blade itself still has infra on there and still uses Chef server, but we are absolutely moving away from that. That is our goal right now. And actually had a good meeting about it yesterday with Chef. So what were our goals around this? Prior to this, we had 2,000 stores, and we threw software out to it, and we didn't have a good idea what was out there or why. So we needed better visibility. We needed to modernize our deployments. Again, we would push applications prior to this to the stores. If a server was down or a system was down, it would often just get missed. We wanted to be able to do configuration management on these and continuous, right? That's the whole point of Chef Infra, right? Is to ensure that we know how our systems are configured at any given time. We wanted to avoid any kind of performance degradation. And we wanted to make sure that there was no drift. There was a common problem, and it's still a bit of a problem, where the help desk would go in and try to do what help desks do, fix the problem. But that led to issues that go in and decide to here's what I need to do, change this file or this file permission to make this one register work. And then, across 20,000 machines or so, you get the result you'd expect, a whole bunch of snowflakes. So we want to stop that from happening so we can guarantee consistency across our point of sale, our KDS machines, all of them down at these data centers. Some of the challenges I've probably talked about here a few times now, but you can read through them here with me. The cafe devices are resource constraint. Cafes don't like to spend a lot of money on their point of sale machines. So we're talking like Atom processors with 2 gigs of RAM running Windows 10, right? You're going to get the performance that you're going to expect. So due to that, we only really actually run Chef at night. So we'll have the client run between like 11 and 3 a.m. so that we don't have any kind of problems during the day. As we get newer hardware, we're changing that model, but that's a significant cost across 20,000 machines. Download perspective, downloads are super slow and prone to failure. And visibility was really difficult prior to putting in Chef and Hab, right? We actually had a homegrown product that would log into the stores and try to gather a query and send it back. If devices were down, they were just missed, all kinds of things like that. Cafe devices have people interacting with them daily. So we need to make sure that they're up and that they're working, right? We can't restart during the day. This is where our money is literally made, printed, and handed to us. So these things have to be up, and we have to make sure that they're working at any given time. So how do we start about this? This is a picture of one of our labs and in our office, as you can see in the Christmas lights above. Unfortunately, we didn't get caught, but that's our security section behind there. They like to put up Christmas decorations whenever they can and hang out in the dark lights. So what do we want to do? We need to take all our known existing configurations and convert it to be a collection of cookbooks. Basic configuration management 101, right? We had a gold disk model. We put a gold disk out there, and then we'd apply patches onesie, twosie with batch files. We don't want to do that. We want to know what every configuration is. We want to get into a cookbook. We want that versioned. Implement testing for the cookbooks, right? So that we know that we're going to have this thing the same every single time. We set up test cafes and throttled the network. When we first set up the test cafe, Mike could tell, you want to talk a little bit about this week. Everything was running hunky-dory because we had a big fat, gig pipe in there, and we realized our problem.
Oh yeah. So we started having these problems at the cafes, and we couldn't figure out because we couldn't reproduce it in the lab. We came to realize that the fact that the download times across a T1 for, say, a package exceed the timeout settings on some of our downloads or some of the HAB settings, et cetera, et cetera. So we ended up seeing a lot of problems in the cafes we didn't see in the lab. So we ended up putting a throttle between our lab and the rest of the world to make it look as close as possible to the cafes. And yay, verily, we found all the problems the cafes were having. So we started applying things like cache and changing timeouts. And I think we even engaged Chef at some point to have them by default change some timings or something to that effect.
Yep. Yeah, I think there was at least a couple of weeks of Mike and I sitting right in front of that thing with the network monitor, watching it to make sure that when we started running things didn't go awry. And of course, we wanted all this under CI, right? We wanted to test every pull request, and we wanted to merge on master branch. We wanted promotions to be done through promotion pipelines, right? And that's how they are done through Jenkins, not through passing it over to operations or anything along those lines necessarily. Chef Automation, Chef and Habitat together. So Chef Infra does what it does really super well, right? It configures the systems. It goes in and puts in the changes that we need on our individual systems, our firewall settings, NTP settings, registry settings, anything that we want done on the box to secure the box or just set it up by operations, exactly what you'd expect it to do. And Habitat runs the apps, right? So it goes out there and says how we're going to run these apps. Greg, you did most of this. Do you want to talk a little bit about it?
Yeah, this was really born out of what we had learned from using HAB for the last 3 years and how it interacted with Chef. And it also sort of worked out that there were like two separate teams who worked on the cafes, and the team who worked on Chef Infra was like sort of a sysadmin type team, and then the people who work on the apps would be like the Habitat type team. So it also like allowed them to release their code independent of each other to break that dependency. Because like if you look at the the stupid meme here on the right, I think all of us have at some point written a cookbook that installed an application, configured it, and maybe reloaded the service and probably did some other things that were kind of unsavory in Chef, and we were able to just take all that and move it into the HAB package level. So really like allow the app to handle its own automation, and that really allowed us to like break up the two teams a little bit too from a development perspective, because the one team really would focus on the configuration and the other team the app.
So your meme basically says this is your brain and this is your brain on HAB. Is that what you're saying?
Yeah.
All right. So deployments, right? How do deployments work? This is actually a picture of one of our first deployments at one of our stores that I took. We were very excited when we did it. So Jenkins is what we're using for our promotions. These are very simple libraries that we've created to do promotions so that anybody running HAB can promote any package, right? So we then have caching built into our compute resource that Red Hat Blade there, so that anything that comes down. So if I've got 15 devices that are all trying to pull down one app, it only gets pulled down one time per store, and then it's cached there. That also helps us later on as devices, if you're going to have 20,000 devices in the field at any given time, some of those are going to go down, they're going to crash. And so when somebody got tech comes out, brings one in there, the apps are cached, right? So if they happen to be plugging it in during store hours, something along those lines, we're not going to be weighing down our T1, which is also competing with like our e-com traffic. The maintenance windows we talk about, it only runs when it needs to. And then it uses the ring for configuration data. This is a big deal for us Mike, do you want to talk a little bit about that? Because we use this quite a bit. To get data to these stores, we don't want, 15 machines pulling in different data. We want to be able to pull it once and pass it around.
Yeah, so there's a little mention to one of the advantages later on in the presentation as well. What we needed was the ability for any of the devices to start up, and things like the ID of the store, which are crucial for our display, for the UI, for example, to know. And many of the microservices need to know what the ID of the store is so that they know how to sign orders, things like that. So those were originally, before HAB, these were in a file. So you can imagine if a device is rebuilt, that file has to be rebuilt as well. That's a major undertaking. After HAB, these were being retrieved by the internal devices from the blade. We also had a problem where the blade wasn't available, and at that point, none of the devices could start in the cafe, which means the cashiers couldn't ring anything up. So what we did is, among many other pieces of information, is we put that cafe ID on the ring. So don't know how familiar all of you are with how the ring information is passed around and how where it's stored, but every device, when it comes up, it will ask, what's my ring? And if it doesn't see anything, it will use its last cached information. So even if there's no devices at all, other than this one that is just coming up, it will still look at the last configuration and at minimum know its cafe ID and some other information that is crucial for it to start up and actually start communicating. So that was one of the big things that we did. It was one of the big changes. Another change was, actually this wasn't a change, this was in the original design. The blade applies information to the ring that tells all the devices which apps to run. We have a standard configuration, which is also S code. It's basically a configuration file, which gets built into a Habitat package and then gets distributed to all the blades. So if we need to make a change to either how an application is started or how it's installed or what the application knows when it starts, we make the change, and in the central file, it gets built, pushed out to the blade, and the blade applies the configuration to the ring for all the devices inside in that ring to pick up. So that makes it both configuration as code as well as very resilient because of the ring design. And there were a couple of other things that we had some issues with, like the permanent peer IDs and things like that. We had to figure out, all the devices had to come up and know who their permanent peer is, and if that was ever changed, if it was rebuilt, we had issues with that. So we fixed that by making the peer ID predictable based on host name and IP and a few other things.
Yeah, when I showed my VP that we could change cafe configuration by committing a file to Git, her eyes lit up, and I wasn't sure if it was with delight or fear, and I'm still not sure, but we're doing it anyway. The last thing that it lets us do is Canary deploys. This was a big deal for us to be able to test a small subset of cafes, right? I don't want to push out new applications, new config to 1,000 stores at once. That's just crazy. There's no reason to do that. Let's ship it out. Let's get it to a small subset of stores and quickly be able to revert it if we need to. Visibility was by far one of the biggest things that we got out of this, right? To be able to take a look at all of our apps that are running across our entire fleet, see what's up, see what's down, see what's disconnected. Again, with the number of stores we have and the number of devices we have, it's very fluid. They're up, they're down all the time. But to have one place to go look and then one place that's API driven to build dashboards off of, it's been absolutely invaluable for us to start to be able to get this information that before used to take, going to another team, asking them to run a process, getting an Excel spreadsheet back, looking through that, searching through it, or going here and running some very simple queries and automate and having some answers really fast. We also do we use Splunk, and this is an interesting one. This is more about our network and its connectivity issues sometimes. That we use Splunk to report back failures, but Splunk only alerts after a certain number of failures in a row. We built the system expecting failures and retrying from the client side, right? So that I tell you to update, it will keep trying to update until that update occurs. But if we fail a few times in a row, there's probably a reason. That's when we get alert, and that's when we look. So reliability, we do survive hard reboots and power outages. That part of that is what Mike was talking about, with the cafe ring data being there. We clean up PID files that are a part of it. We retry with exponential backoff. I'm not sure what that even is. Greg, that was you.
Yeah, just the fact that we want to keep retrying, but we don't want to do it in a really quick loop. We want to like slow it down, but don't stop.
Yep. And caching the HAB packages on the blade. We talked about that a little bit earlier. It makes a massive difference. And so, the life of a tech now, when they go out to the store, when they plug in a device, to not have to worry about what versions are out there, to have to worry about what do I need to set this to have it plug in and have the device come online and say, okay, I am a point of sale device. I listen to this specific channel. Give me everything I want, and having it cached on the blade has those machines back up and ready to go literally in minutes, and they're done right? It's not a guesswork, it's not hand done. And that's a really huge benefit to making sure these things work. You see the smiling, happy people here at the point of sales. But the truth is, they are smiling happy when they work, and they are not when it doesn't work. And I don't blame them one little bit. This is what they do, right? And when it doesn't work, the customer's in their face, not mine, right? So these are my customers. I want to make sure that they're incredibly happy and incredibly smiling, and I can do that by making these machines work all the time. And that's the biggest win here for everybody. So I think that's all we have, unless anybody has anything they want to add. Feel free to chime in at that point if you do. Otherwise, we can start with questions.
I was just going to say about the last slide that, the way we built our system to be resilient like that was to deploy it into like the lab environment and go through and actually like do chaos engineering where we're like unplugging devices, turning the power bar off, just treating them, like garbage, and seeing why a service wouldn't start when it comes back up. And hopefully some of these things that we built can be, shared with the community at some point.
Yeah, my comment is one of the coolest things as a previous system administrator is being able to plug a device in, and as long as it has the right host name and IP, that's all I got to worry about. It'll go and grab everything it needs. It'll configure itself, and it's back online in, like I said, like Scott said, in minutes, without any input from me, without me having to copy any files from the previous device. What if the hard drive is dead, et cetera, et cetera. So plug it in, and we're done.
Okay, awesome. So we have a couple of questions here, so we'll get started. One question here: how varied is your hardware in the stores, and is coding for different hardware or operating system configurations difficult?
So again, in the stores, we typically have Windows 7 or Windows 10, but we do have different base images. Right now, the scope of our project has been around the point of sale and KDS machines. As we bring in the other devices, the effortless pattern, we're actually working on redoing that right now. That will allow us to be able to manage them really easily, with policy files and that type of approach. It's really not very hard.
There was a few challenges around, a system that's running Windows 7 is running a different version of PowerShell than a system running Windows 10. So there were parts of the system that were we had to take it from not managed by HAB to be managed by HAB, and we did a lot of that scripting with PowerShell. And there was a bit of a challenge, but it's more just like test with the lowest common denominator, right? Like write everything so it works with Windows 7, and usually it works with Windows 10 as well.
Yeah, there were some registry things too, if I remember right. You're right. I didn't think about it that way. That where you change the registry setting on Windows 7 and it didn't work on 10, so we had to do a little digging with that. Obviously, the more you can get those to be the same, the better, right? I think everybody would agree with that.
Yeah. Since you're talking about working on Windows, is these are GUI applications, right? So that's pretty different from what we see most of the time for this kind of management at this scale. What kind of challenges do you see with working with that kind of application?
So, Mike, do you want to talk about that? So, what I'm hearing is how do we make a UI work with HAB,
Yeah.
and some of those fun challenges that we had. You and Matt could probably both talk about that a little bit because there was some funness with that.
Yeah, there's really only one application that runs on these devices that runs in the foreground as a GUI. That is the Cafe browser, and it just gets configured differently on a kitchen display than it does on a point of sale system. But in both cases, it has to run in the foreground as a specific user. And we really have found no easy way to do this other than starting it with a Windows scheduler and configuring it so that it runs in the foreground and is able to interact with the desktop. We've tried many things. There really is no easy way other than again creating a scheduler job and then launching it so that it launches the application in the foreground and it can interact with the desktop. The previous iteration of the control software, now it's HAB, was running interactively, so it could launch the application interactively. But HAB runs as a service, as a Windows service, so there was no really easy way of doing it. So all the other applications are microservices that run in the background that are accessed via either HTTP or some API. So those were not the problem. But the biggest problem was the one that runs. It's the same application that if you look at the display system that you see, the one with all the squares and your orders on them, as well as the POS, which runs on a touch screen and allows the cashiers to ring you out.
Cool. So kind of follow up on that. Does customizing for the different Windows releases happen in the Habitat configuration, or does it become part of like your effortless configuration? Or are you pulling that down from the blade? Does it just live on the ring? Where are you actually doing some of that stuff?
So the short version of that is pretty much nowhere, because the applications that run, and I'm assuming this is a question specifically about the user interface or the UI, the application runs abstracted enough to where it doesn't care whether it runs on Windows 7 or Windows 10.
Oh, nice.
Now, the configuration that HAB does in the background to make this happen does happen in the effortless package. There are certain things that only run on Windows 7, certain things only run on Windows 10, or different ways of running them on Windows 10 and Windows 7, for example, setting the resolution. Some of the API accesses aren't available on Windows 7 that are on Windows 10, things like that. But the application itself actually is not designed specifically or written or built or compiled for Windows 7 or Windows 10. It's just, in most cases, we're running Java application or a Python GUI, which will pretty much run, as long as you provided its runtime, it will run on any OS.
Cool. So as far as like your sort of migration and your sort of life towards Habitat, what kinds of other stuff did you find that you were replacing? And are you working with like completely new sort of pipelines, or were you sort of building this into things that already existed? Was there like other sort of migration process involved in the whole thing?
So we had our own custom deployment tool that we used, and we're moving away from that as part of it again. That was very much based off of a push model, which to manage 2,000 remote locations, 20 some odd or 30,000 remote devices, it's not going to work, right? So we were able to retire that. And so most everything is done through your standard CI/CD tools, right? It's all Jenkins, Artifactory, Habitat and Chef Infra as you would expect it to be. But yeah, we were absolutely getting rid of homegrown tools that were out there and replacing it with this, and it's made a huge difference in terms of consistency, in terms of reliability, and in terms of visibility.
Awesome. Here's one. Appears that the ring solution was a big deal. What was the origin of that solution, like putting everything on the same ring? And did you end up with any snags in that setup or experimentation before you sort of settled on that final topology?
Well, the general idea of the ring was there was just certain information that every machine had to have, and it needed to be passed to it from the blade. But yeah, there were certainly issues along the way. Mike, do you want to talk more about those? Or the ring is much more your baby, but it really, the whole idea of the ring was that that was our solution to the fact that we needed to, at any given time, have everything down in the store except one point of sale device, right? To be able to ring in stuff. And it needed to have certain information. It needed to hold it. And once we found that those rumors or that file persists to disk, we found that to be the easiest way to do it. And then the blade could reach back one time by an API call to our data center to retrieve other information and pass that on to the individual machines as well. Mike.
Right. So the ring solution, that's actually something that's provided by Habitat out of the box.
Yeah.
And I'm assuming that the original design or the original purpose of it was to share information among applications. If you set up an application to have 2 or more instances or minimum of 2 instances running within some little microcosm like a mini data center or whatever, they will talk to each other and they'll say, hey, I need one more application running, and then a member of the ring can spin up an application. That sort of, right? So the ring information, this is something that's exposed to Habitat in the form of configuration. So we just took advantage of an existing solution. I suspect that Chef meant for this to be both an internal as well as an externally accessible configuration source. So we chose it because imagine 15 devices that come up within one cafe requiring information from the data center. They're going to fight each other over the T1. Here's another problem with the T1, right? If you have all this in a data center and you got a gigabit connection to everything, you don't have to worry about these things. But if you have 15 and 20 devices all coming up and asking for, hey, I'm cafe this, what's my configuration? What do I need to do with credit cards and how do I route this? If all that information is available on the ring, when the application comes up, it'll ask, what's my configuration? And it's available either locally or it's available on the ring. And any new information that needs to be updated is updated by the blade, because the blade is the one that goes and asks, hey, is there any new configuration for this cafe? And if there is, it will apply it to the ring. So immediately all the devices will see the information, and any new device that comes up, since that device knows it is a member of this ring, it will ask the ring, do you have this information? As opposed
So Mike,
to, again, reaching out to the data center and getting all this.
There were some gotchas, if I remember, and I'm trying to remember specifically what it was. But it had to do with how that ring data was persisted and having to, like right now we go and we create a custom name for the ring data file. We drop that file specifically so that it's a known name. Is that right?
The issues that we had were if we rebuilt the blade, the permanent.
Yeah. So the permanent
that was
peer,
one of the biggest problems.
Yeah. So you end up with the permanent peer named in the RST file, I think is what it was.
Yeah, his ID or his GUID.
Yeah,
his ID
all right. So that was
recorded in every member's file.
Yep.
So if that changes,
yep.
So
it's not done by host name or IP. It's done by UUID. So your permanent peer, when you go in there to create that ring to talk to him, it says, okay, cool, everything's good. It writes this UUID into that rumors file, into that ring data. And if you replace the permanent pier, and when you try to reach back, you have a problem. So what we ended up doing, and Chef knows this, they're working on it. They have this in there in their backlog to take care of, is that we write once a blade, or once the permanent pier comes up, we write to it and say, set the UUID to this, which is a hash of their host name, so that we know what it is every time. Right?
Right, because we do rebuild on not a regular basis, but occasionally we have to rebuild the blade, which is the permanent pier. Any of the other devices don't care because they come up,
Right.
they know that their permanent pier is the blade and its IP is this. But if we have to rebuild that machine, then all the ring becomes a separate, a headless monster, right? Because it no longer has a permanent pier, and it has to have a permanent pier to go and ask for things like what is on the ring, and there are a few details that, you know. But what we ended up doing is when HAB is installed on the permanent pier, that's the biggest gotcha, is we ended up having to come up with a predictable GUID, which is, like Scott said, basically a hash of the machine name and a few other things. But it is always predictable, and it's always going to be the same, even if we do rebuild that permanent pier, that blade in the cafe.
Oh, that's interesting. So that ends up becoming more of a permanent location ID for that ring versus just transiently attached to that individual instance. That's super interesting. Like some of the examples that we have, and if folks have been through our Habitat tutorials and some of those things, like hopefully this is sort of clicking things in your brain about how the rings fit together and the pier configuration happens. This is a much more, I think, interesting practical example than maybe what we've got in some of our tutorials. Absolutely fascinating.
And one of the things I just wanted to say about it too was, one of the innovations here was, like, Chef gives us the tools to be able to have config apply to a ring. You can do it remotely if you have, the secret key to do that. But what Panera was able to do was they wanted to version their configs and apply them at the blade using Chef. So I thought it was a cool way for them to, version that configuration file in Habitat, package it in Habitat, and then when Chef runs on the blade, diff the config that's on the ring with the config that's in the file, and then apply it when it's different.
That's super interesting. Absolutely. So here's the next question. It looks like this solution is right-sized for the stores. Do you have any plans to expand some of these solutions beyond the stores to other parts of the company infrastructure? And if so, what challenges do you foresee there with that kind of application?
Yeah, so we're using it extensively in the data center as well. So our e-commerce platform, as they are rewriting their services and breaking them apart to be more microservices, they are absolutely following this pattern. The bigger issues that we ran into with them, so those are all going to be Red Hat systems running Spring Boot apps, super simple. The bigger issues we ran into with them there were around these permanent piers and making sure that we had them set appropriately. They wanted to be able to do rolling updates in there, right? So we want to be able to do push updates to our services, in what we call PM chill, like 3 o'clock in between lunch and dinner rush. We want to be able to do that without taking an outage. So we were able to write into the hook to do a rolling update, to post to the F5, hey, take me out of the group and put me back in when I'm updated, all that kind of stuff. We had to come up with a model where we said that there was a minimum, a standard basically that said that there was a minimum of 3 permanent piers. So if it's 3 or less systems that are needed, each one of those is marked as a permanent pier. If there's 3 to N number, the first 3. So, if you name it server 1, 2, 3, those are our permanent piers, 4, 5 through 1,000, all point to 1, 2, 3. And that ensures that those permanent piers are up. Otherwise, you end up in a similar type of a predicament. And that's due to the rolling topology, right? So they need to be able to have that permanent pier to be able to talk to each other, to know they're up, to ensure that their rolling updates are working successfully. But otherwise, I mean, they've been working great, and Ecom's hopped on board. All our other platforms that are data center driven are actually hopping on board as well.
That's awesome. Another question referring back to the point of sale systems. How do you manage the register IDs for those?
I'm not sure, that's a little specific. How do we the register ID?
Host name.
By host
Yeah.
name? Cool.
We have n number of registers. They're all sequentially numbered, and they're all have specific host names. Register 1, register 3 with an IP of .101, .102, .103. And that's basically how the devices figure out what they are by the host name and by the IP, and what to download and how to run and what applications to actually run.
Cool. All righty. And if anybody else has any other questions, you can add them there in the Q&A panel. Let's see if all my questions got answered, since I had a list here as well. From a sort of like a DevOps standpoint, like, does this change the way, like, you mentioned you have like 400 people sort of in your org on this stuff. Like, has this changed the way people work? Has it changed the way you get things shipped in a larger sense in the sort of putting all this stuff together for Habitat specifically?
For sure. I mean, I'll tell you, the biggest thing is, prior to us doing this, at any given time, and it used to drive me batty, I won't lie to you, there would be 15 people on a call on release night, and they would go call over to ops, and ops would say, "Shall I push the button?" And they'd say, "Yes, you shall." And then everybody would sit there and watch. It was to the point when we first started, that like, especially with just the infra stuff, we had the Chef servers, we had the Red Hat servers running on Splay, so they would only check in every 45 minutes, and we're designing this knowing that we're going to 2,000 stores, and they hit deploy, and they're like, "Nothing's happened." And I'm like, "Yeah, it's just going to run here sometime in the next half hour, and then it's going to pick up the changes, and then it's going to apply those changes, and it's going to work." And they didn't like that very much. Once we got out past 10 to 20 to 50 to 100 to 200, they understood the idea. And now it's one guy at one time at night hits deploy, hits a button in Jenkins while everybody's happily asleep, and they call us if there's a problem. So absolutely, those deployment night calls, like, those are gone. And even the pushing the button, I want to get rid of. I want that. There's no reason that shouldn't be just a schedule, or the pipeline shouldn't be able to call to ServiceNow and say, "Hey, it's Tuesday night. This is when I do this deploy. Is it approved? It is approved. Okay, go." And then send out send out an alert if there's a failure of some sort. But it's made a tremendous difference on our deploys, for sure.
That's awesome to hear. Excellent.
I'm going to add to that real quick.
Yeah, go ahead.
The fact that we can monitor things and automate is awesome. But what's even more awesome is the fact that everything you see in Automate is reachable via API call. As a matter of fact, the front end of API doesn't make any calls to, the front end of Automate doesn't make any calls that are not exposed. So everything you see and then some is available in Automate. And we've had a few bright go-getters actually create monitors and web front ends that go and retrieve this information from Automate. So during deploy time, they don't even go to Automate because there's too much information, et cetera, et cetera. They want specific information. So they've written a query that is displayed on their specific monitor, and that tells them it's already gone to this many devices, this many failed, this many succeeded, et cetera, et cetera.
Yeah, we're currently converting about 40 cafes a night to this. So we have 750 cafes live right now. The goal is to be complete with all of our corporate stores, which is right about 900 at the beginning of June. So we're right on target. But the guys that are doing it, that are doing the overnight shift, they're really pushing a button and then looking at a monitor for red or green. And that monitor was built off of Automate and Splunk. And so they're able to push a button, watch the whole cafe convert, and then, look back and say, "Hey, were there any problems?" And if there were, they could go in. Sometimes, it's Windows, right? Sometimes the machine was set to apply the config and reboot, and they don't. And right, so their general instructions are reboot the machine. And that's about the extent of what they need to know, other than if things are red or green, which is great.
Is that the same sort of method that you apply for like operating system patching and all that other kind of stuff?
Operating system patching is a whole different process. We're trying to bring that into this fold at this time. We'll kind of leave that there.
The future work left for the user, absolutely. You've mentioned a little bit about some of the other tools that you're using. Like, what else is in your CI/CD pipeline? You mentioned Jenkins and Artifactory and some other things. What else are you using in there?
For Chef and Hab, really nothing else. Mike, it's our standard Jenkins.
The pipeline we set up for the Effortless Cookbook, it's using Jenkins for sure, but it really takes those 3 main images from the cafe, like the Windows 7, Windows 10, and then the kitchen device, and spins them up using Vagrant, and then basically like treats it like a store, and installs the cookbook, installs all the apps. Then we run inspect checks, and that's how we test all the PRs and master merges.
Yeah, and we use Vault. I forgot about that too. So we use HashiCorp Vault
Okay.
for securing keys and all that.
Cool.
Jenkins really is the heart of all of it.
Yeah.
The cookbooks and Hab packages, they all get spun up on Jenkins nodes, which have images available to them for Vagrant to spin up Windows 7, Windows 10, BOS, KDS, etc. Then there's a standard set of servers, Builder, Artifactory, and that's basically it.
I will say that Panera has the most comprehensive, well-managed Jenkins server that I've ever come across in the wild.
Yeah,
Well, it's awesome to
what
hear.
makes it special? Like what kind of sneaky things do they
It's the
do?
managed pipelines, I'm guessing. I mean, we built out some serious pipelines, right, to be shared across it. So everybody uses common shared libraries, if you will, for their build. So if you are building a Maven Java app, Maven, it's going to build the same way. If you're building a cookbook, it goes through the same pipelines, right? And so you're running the same tests every single time. It guarantees consistency.
Very nice. I'll have to get you guys to talk about that more sometime too. All right. Brandon Skilton has his hand up. I have not tried this yet, so we're gonna try and Brandon, do you have a question? I can allow you to talk there. Let's see if that works. Are you out there, Brandon? All right. Well, if you come up with your question, put it in the Q&A. One more. Let's see. Are you managing your Jenkins with Chef?
We are not. I'm a little ashamed of that. I literally say that you're really good at CI/CD when your CI/CD tools are under CI/CD, right? It's hard to put stash under CI until there's a stash or Git, until there's a Git that exists, right? And so the first thing you do, right, is you build Jenkins, and that allows you to build pipelines, allow you to do things. And once we started down the road, we've absolutely had everybody go, oh my God, we want some of this. And so we're a small team. There's 4 of us, and then a manager, right? I'm useless. And so there's 4 guys working on things at any given time. And so coming back to our own stuff has been difficult. We have, however, come back and put, Automate and Builder under CI, right? They made the tool super simple to be able to do that, but we have not done that for Jenkins or for Artifactory, for that matter.
Yeah, that automated conception going on there, right?
Right.
So for the rest of your deployments, like the other stuff that you're using, do you use anything in the cloud? Are you working still on-prem for the rest of your services that way?
So we absolutely use the cloud. We have some major platforms in the cloud. Our back of house, our marketplace, those are all GKE, and those are running Kubernetes.
Oh, nice. Wow.
We'll use Jenkins for that too.
Jenkins, everything starts with Jenkins, and that goes to Spinnaker for deployments.
Oh, that's interesting. Okay, very cool. You guys have a lot of cool stuff going on there. All right.
For 4 people, we did all right.
Yeah, I think so. Yeah, busiest 4 people we've talked to in a few weeks. That's for sure. All right. If anybody has any more questions, we're almost to the top of the hour, so we have maybe time for one more. Guys, is there anything else that we haven't hit on that you'd like to mention before we break?
I would just say, I mean, I've been working with Chef now as a partner for probably 5 years. It started when I was at MasterCard and carried over. And honestly, to anybody thinking about it, I'm not trying to sell it. They're a fantastic partner. And that's really the reason that we stick with them, right? There are going to be snags in anything that we do, but they to me, they're like another department in our IT. And we really work with them that way, and that makes the biggest difference in the world to me.
Yeah, I second that. I mean, we had at the initial deploy at the stores, we had a pretty major issue that required a code change on Chef's side. This was accessing automated. Remember, if it couldn't stream, it wouldn't come up online. And I think they turned around in less than 24 hours and had the code out and tested for us in a matter of 2 days. So yeah, Chef. And again, same thing. I'm not trying to sell them, but I really enjoyed. Chef has definitely been one of the best vendors that I've ever worked with, and I've been working with vendors for a long time.
That's great to hear. Thank you guys so much. All right, we'll wrap it up. For other things that you might want to look at in the ChefConf package, Shuttle Ops does have a presentation coming up about their new platform, and that'll be, if you're seeing us live, that's next week. If you're seeing us as a recording, you can find that in the presentation list. I'm sure it'll be great. And everyone else, thank you for coming.
Thank you guys very much. Have a great one.
Thanks.
Stay safe, everybody.